Okay, we're looking at rational exponents. And this section, it looks like we're just going back and forth from radical form, so that has a square root, to exponent form, which is what we call a rational exponent. So the main thing I need you to remember, I took this from your notes, from the textbook, is this. That the denominator is the index, and the numerator is the exponent. So we're going to do a couple examples. I took this question from a self-check, so you'll probably have a similar one, maybe the exact one if you're lucky. And we're going to rewrite this is exponent form, into radical form, where we have a root. So notice your possible answers. They're all a root of 6. And that's because your denominator, that's the largest number, is 6. So we want to rewrite 1/2 and 1/3 with the denominator of 6. So I want 1/2, I want to rewrite that with denominator 6. And I'm going to do the same thing. Then I want 1/3 with the denominator of 6. And the common denominator will have a common index number. So think back to finding a common denominator. We're finding a multiple. So 2 times 3 is 6. So I would have to multiply the numerator by that same number as well. So 1/2 is the same as 3/6. So notice that if I reduce 3/6, I'm going to get 1/2. These are in fact equal. We're just rewriting it. So over here on our other one, 1/3, if I times 3 by 2, I'm going to get 6. And I have to also multiply the 1 to get 2. So again, if I reduce 2/6, I will get 1/3. We're just taking this value and we're rewriting it. So now, instead of 3 to the 1/2, I'm going to have 3 to the 3/6, and then x to the 1/6, and y to the 2/6. So we're doing that because now we can put this whole thing under root 6. So I'm going to have 6 as my root, and then these other exponents that are left at the top, those stay under the root. So this becomes 3 to the 3rd. This becomes x to the 1st. And this becomes y squared. Okay. So 3 to the 3rd, I'm just going to simplify this. 3 to the 3rd is 3 times 3 times 3, which is 27. I don't have to write that degree of 1, and then y squared. And that's our answer. So if we come over here, we'll see that right here. Okay, so you're going to see those in your self-check. Get a common denominator. Oops. Okay, let's do the same thing here. So now we have 16 and 6 and 6. So I'm looking at 4 over 16, which I can see can be reduced. So I'm going to reduce this. I'm going to divide these both by 4 and get 1 over 4. And I also have 2/6, which can also be reduced. That's kind of weird. To 1/3. And then I also have 3/6. that can be reduced to 1/2. We just did that one on our last problem. So actually, I have fractions 1/4, 1/3, and 1/2. And I need a common denominator. And if you can't think of one, the best thing to do is try multiplying some of these. So I'm going to take 4 times 3 and get 12. That works for those. And it also works with 2, because 2 times 6 will equal 12. 3 times 4 will equal 12. 4 times 3 will equal 12. So that is common for all these numbers. And what you do to the denominator, you have to continue in the numerator. So I'm going to multiply all the numerators by those same numbers to get fractions with the common denominator. So when I rewrite this, I'm going to bring it down here. I have 3, but instead of 4/16, we're writing it as 3/12. And then x, instead of 2/6, we're writing it as 4/12. So we definitely had to do a lot of changing here. And y, instead of 3/6, we're going to write it as 6/12. So the common denominator gives us a common root. So we have a root, or a radical, of 12. And then we're going to finish 3 to the 3rd. We're taking the numbers with the numerator. X to the 4th. Y to the 6th. And this is just like the one we did last time. We can simplify 3 to the 3rd as 27. And I can see over here, that's an option right there. So when you're going from exponent to radical, common denominator on your fractions. And then once you're done,